back to another calculus tutorial where last video we were talking about improper integrals. We were doing a introduction. We learned that infinity was not a real number, thus you weren't able to evaluate a typical integral, and that we had to convert it into a limit. And in this case we used a function 1 over x squared converted over to a limit, and we substituted that infinity for some variable t, and we took the antiderivative and then evaluated that function accordingly, and we came up with a solution of 1 for the integral of 1 over x squared dx from 1 to infinity. In this example I wanted to use a lower limit with a negative infinity and some real number up here. In this case we'll just do 1 again to keep it simple, and the function we'll be using is e to the x. And so we're just going to follow the same steps that we did last time. Step 1 was to convert into a limit, and we're going to be using t again. Substituting for a negative infinity, and so since the negative infinity was the lower limit of this integral, that is where the t will go, and then we write in that 1 e to the x dx, and that is the first step. And now we can find the antiderivative of e to the x, which is just e to the x. To the x from a lower limit t to 1, and now our limit. Once we evaluate this integral, I have e to the 1 minus e to the t. And so now we can insert our negative infinity into this expression here, and then finish the problem up. So we have e minus a e to the negative infinity. And so the negative is just a reciprocal, so I like to rewrite it as, as a fraction to keep it simple. It's easy to visualize. And so since we have e to the x and we know the plot for e to the infinity, so that's this axis will be t, and this is your e to the t. You can see that this one just continuously gets higher because it's an exponential function. So you know that this is a infinity, e minus 1 over infinity. And anything that's if an infinity is in the denominator, it goes to 0. So you get an e minus 0, and what you're left with is just e. So, let's go with green. And so what our solution ends up looking like is the limit of t as it goes to negative infinity will equal e. And this is our solution.